Hey guys, so excuse me, chapter 6, our last chapter for paper 2. Obviously, it's not going to go in your evidence folder, but I want to get you through the whole curriculum. So, numerical solutions is when we have an equation that cannot be solved algebraically. Okay? But there are methods to calculate an approximate solution. We will be graphing in this chapter, so you might want to be working on graph paper. So, if we wanted to find the solution of y equals x cubed and y equals 4 minus x. So first we have to graph both of these. So y equals 4 minus x. That means I have a y-intercept of 4 and a slope of negative 1. X cubed starts at 0. 8. So you want to look at where they intersect. It's here. So that's not on a lattice point, so we don't know the solution based on the graph, but we do know that its root is between 1 and 2. So the root is going to be called alpha. And the question wanted you to prove that there would be a root between 1 and 2. They might also ask you to rewrite the equation by setting them equal to each other. So x cubed plus x minus 4 equals 0. And the solution to this equation is somewhere between 1 and 2. So there's another way to figure out the numbers where the root is between. So if it says show by calculation that f of x equals x to the 5th plus x minus 1 has a root alpha between 0 and 1. So you're going to plug in both 0 and 1 into our equation. So f of 0 is just negative 1. F of 1 is 1 to the 5th or positive 1. Now, we know if there's a root if the sign changed. So the sign change means the root is between those numbers. Okay. So here, the equation will say cosine x equals 2x minus 1. It has a root that is less or greater than or equal to 0 and less than or equal to pi over 2. So you'll be asked to graph both of these equations. Y equals cosine x and y equals 2x minus 1. So I'm going to start with y equals 2x minus 1. Actually, I need axes first. Drawing tool. Minus 1. So here's my equation for y equals 2x minus 1. Cosine x, right? Cosine x starts, if I have cosine of 0, that's going to be a 1. To find the x-intercept, I set the cosine of x equal to 0. The x-intercept is the inverse cosine of 0 and that equals pi over 2. That's my x-intercept. Now, in order to graph it on here, I'm going to change it to a decimal, 1.57. So that's approximately here. And we're only really concerned with the part of the graph where they intersect each other. So yeah, the root is between 0 here and pi over 2 here. Then verify by calculation. So this means I'm going to need to move all of this to one side so it's equal to 0, and then plug in 0 and pi over 2. So it will be cosine x minus 2x plus 1 equals 0. We'll plug in 0 and pi over 2, and we're looking for a sign change. Cosine of 0 minus 0 plus 1. Cosine of 0 is 1, and 1 plus 1 equals 2. Cosine of pi over 2 equals 0, minus 2 times pi over 2, which would be pi, negative pi, plus 1. That's approximately negative 0.24214. Sign changed. We've finished verifying. Now in 6b, we're going to talk about the iterative process. So if you're in engineering, you might have heard of this before. It means you keep trying things and improving on them until you get to where you want to be. So let me show you how this is going to work. Let's say f of x is x to the 5th plus x minus 1. And let's set that equal to 0. We're going to find that there's a root alpha between 0 and 1. So first, we need to solve this for x. So x to the fifth equals 1 minus x, and then x is the fifth root of 1 minus x. This is important because we're going to keep using this during the iterative process. Now, our root needs to be between 0 and 1. So we're going to pick a number in the middle and start there. Let's say x is 0.5. Well, plug 0.5 into this equation and you're going to get an answer. I would suggest this chapter will be a lot easier for you if you're using the store function on your calculator. So I'll type 0.5 store x. Then type the fifth root of 1 minus x. So I get 0.87055. And you want to keep this to a lot of decimal places until you get to your final answer. Now, you have to plug this number in for x. So, once you got that answer, now store that value as x. Go back up and select the equation you typed in. Okay. Store this as x. Go back up, select your equation again. Now, as we keep doing this, the numbers will converge or get closer to the actual solution. So we have to keep going until their 1 or 2 sig figs are the same. Now, 0.87 and 0.66 are totally different. So are 0.66 and 0.80. So you have to keep going. That's why storing it in your calculator is so helpful. So I'm plugging this in. I got 0.72198, 0.77413, 0.74263, 0.76228, so 0.74 would round to 0.7. 0.76 would round to 0.8. So those aren't close enough yet. Okay, so these numbers are getting really close to each other. That means we have our approximation. In this example, they wanted 1 sig fig, so my alpha is approximately 0.8. So this may seem annoying, but if you get really fast with your calculator, it's not that big of a deal. Well, let's try another. X squared plus x minus 3 equals 0 has a negative root alpha. Find alpha to 2 decimal places. Okay, let's solve for the x. X squared plus x equals 3. X times x plus 1 equals 3. X plus 1 equals 3 over x, and x equals 3 over x minus 1. So this will be the equation we're going to use to plug in to plug our values into. It also tells me I should start with negative 2.5. Store that in your calculator. Type in your equation, 3 over x minus 1, and I got negative 2.2. Just going to keep storing. Selecting my original equation. Okay, so 2 decimal places. I have negative 2.30. These all round to that. So that's my approximate. Approximate alpha is negative 2.30. Okay, final example. E to the x minus 1 equals 2x. There are 2 roots. One root is 0. The other root is between 1 and 2. So first it says, prove that there is a root. Calculating that there's a root between 1 and 2. So that's where we're going to move everything to one side and plug in 1 and plug in 2 and see what happens. So e minus 3 is approximately negative 0.282. E squared minus 1 minus 4 is approximately 2.389. So there was a sign change. We're done with that part. Now we want to find beta to 3 sig figs. We need to solve for x. So first I'll move the 1 over. And remember, to get rid of an e, we do the ln of both sides. So here's where I'm going to start with my iterative process. And I'm going to start with, 1.5, halfway between 1 and 2. Okay, plug in 1.5, store it, plug in the answer. 1.38629, 1.32776. So these are not rounding to the same numbers yet. 1.2962, 1.2788, 1.2691, 1.2636, 1.2605, and 1.2605. Okay, so these two are exactly the same when I round. So my answer to 3 sig figs for beta is positive 1.26.